Hello everyone, this is Pranava Rao and today's video we'll be solving another challenge from MetaCTF. This is going to be a reverse engineering challenge. So let's dive in. Coming to the challenge. You have been locked in a secure wizard jail, but the overlooked guards forgot to take away your magic wand. Can you break out of your cell? Download the jail plans here. Connect to the challenge through the netcat session. Okay, so let's download the jail plan. Saved in my downloads folder. Then it says connect to the challenge through this. Let's copy this. Copy. Then I'll open up my terminal. CD downloads. Yeah, and I can even see the zip file here. Okay, so now let's connect to the session. Break out of the jail. Choose an option. Use magic wand or bend magic wand. Okay. Let's say enter your spell. Hacker hacking the cell. Oh no, the spell failed. Okay. Hmm. Hacker. Okay, what about some special characters? What would this? I'm just trying out some characters to see if it gives any other errors other than oh no, the spell failed. It says invalid input. Try again. Okay. So fine. Some random text, some numbers. Says invalid input. Try again. Okay. So it's trying to do some comparison or something. Now what about enter one or two? Okay, this says one or two. No. Fine. I'll just press one and then copy and paste this. I'll paste it here. Oh no, the spell failed. Okay, so the spells fail. It's I guess it's trying to compare or it's trying to do something. Now what about the option two? Option two. Enter the location on the band you would like to mend. An integer. What will happen if I enter a string? Okay. Here I'll put a integer. Mending failed. Invalid. Okay, for int. Fine. Fine. Okay, let's give some integer. And one, two, three. Code CO code is malformed. Okay. Okay. So what I'm thinking or what I'm guessing is that this is trying to use the spell or what the input the user is giving and then trying to compare, or it's doing something where but there's an interaction and there are two options that the users can use, that is one or two, right? So I clearly don't know. Let's look at what we have got in the zip file. So unzip wizard wizard w. Okay, move the chal folder. And here we can see the Docker file, flag.txt and jail.py. So it's a Python file we have got. What's then the Docker file? It's just about building it, right? Yeah. Flag.txt, that's nothing. That's redacted. Now jail.py, cat jail.py, and we see a Python code here. You know what? I will open this in my Sublime text, jail.py. Yeah. So here it has a good font and all those things. From types import code type. Okay, it's importing code type. Then it's a function def magic wand. Let me ignore these functions. When it's called, let's go and then read it. So the print function breakout of jail. You know what? Let's have a side by side comparison by also running the two here. Now I forgot the session. I have. Okay. command here, paste it. Now this in my side. So it says break out of the jail. That's what we are here. And then it says mend left is 5. Okay, it's the variable that they are declaring. Then comes while true, print, choose an option. That's what is here. Choose an option, print 1, use magic wand, and print 2, uh, mend the magic wand. Then while true, it's going inside a loop. Options input, enter 1 or 2. That's what is this, where we have got an option to enter 1 or 2. If option in 1 or 2 break, okay, or else invalid input. So yeah, if it is 1 or 2, it's going to take it in. I had a space here, so that's why. So, and it has different functions there. Okay. So if not, invalid input. That's what we got here when we had entered this enter 1 or 2. We got invalid input. Try again. Okay. So fine. So then if option is 1, enter your spell. Yes. Now if I give it as 1, it says enter your spell. And then try, they're putting it inside a try function. So result magic wand dot spell. So now the function is being called the magic wand. Okay, so this is the spell. No, the spell is being passed here. Then spell is equal to this plus spell and reverse. If I'm right, this is reversing it. Also adding this what do you say, approximate sign or wiggly sign, whatever that is. So it's adding that in the beginning and then reversing the entire spell that we gave in. And then spell 5 to 10, that is the fifth letter to the 10th letter, all of them. It's going to save it that, then, oh, the reversed format, then add a wiggle sign in between and then the first 5 characters. Okay, that's good. Then spell 1, it's going to add another wiggly sign to it. And then return val. Okay, return val. It's a system function, if I'm right. So what val does is, if I go to Python 3, now imagine I say x is equal to print uh, 55. Okay, so imagine this has been given as a variable to the value x. Now when I write or use the command eval, it's going to run whatever is there inside x, and that's why we get 55, right? So it's going to act as a command which is going to run the input what we have given. Okay, so fine. So it's trying to compare, or it's going to take this and then reverse it. You know what? Actually, let's copy this, open one more. I'll paste this in the same code. And now I'm going to save this in my downloads here itself as test.py. Okay, now here I can show you by every step by using print function. So print spell, then again print spell, then again print spell. Okay, so before it actually returns, no, it's basically going to execute whatever is going to be there in the spell at this point, right? So let me save this in. Then using this itself, I'll build Python, build with Python. Okay, it's down here. So break out of jail, choose an option. I'll use 1 because that's what we're calling in. That did nothing. What happened? Did I break the code? This is not fun. What happened? Okay, so let's uh, run this through the terminal itself then. Come here, exit. ls, we see the test file.py. So now Python 3 test.py 1. So enter your spell. I named it as hacker. We can see at each step it's going to first add those symbol and then reverse it, and then from 0 to 5 it starts from 0. So 0, 1, 2, 3, 4, and 5. So it's going to take just the characters of A and H. Oh, the reversed of it, no? So from here 0, 1, 2, 3, 4, 5. So from the fifth position it's A and H, and then it's going to add the symbol. Then it's going to be printing out from the beginning to here. So then at last it added this. That's what was the function that was happening here. The whole step is this one, and it's sending Hono the spell failed. So it's what it's trying to do is it's trying to print this one. Okay, so that's fine. I understood. It's trying to execute this as a command. That's not possible. Now let's go down. Now here it is. Oh no, the spell failed. Right? Yeah. So it's going to try, and if it gets an error exception, it's going to come here. Fine. What if I enter 2 now? So the option 2 is entered if men's left is is less than or equal to 0. Then unfortunately the wand can no longer be mended. That's this one. So if it is okay, it can, so then you can only have 5 trials to do it or mend those things. Now if not, it's going to say location is equal to input, and then enter the location where you would like to mend an integer. Yeah, that's what we got from here. So enter the location of the van where you want to do it. Fine, and then after I press enter, it's going to take enchantment. That is another input. Enter the enchantment that you would like to use. It's also an integer. Fine. So try. What happened? Okay, come down. So it's going to try the magic band is equal to mend. Mend a function. Yes, a mend is a function, and the magic band is being passed there. Okay, it's not taking as an input, but fine. And then the location, which is our input, and the enchantment, which is again our input. 2 bytes. Okay, it's sending in the bytes format. Okay, understood. So, and also in the form of integer. Now let's go back to the definition here, the function here. So it's going to receive all those parameters. Then comes the co is equal to magic dot. Okay. So they're using bytes. So it's called code object, I guess. The short form of co is code object. The short form is co. That's code object. And then magic band code is equal to code type. It's a function which is going to what do we say, like import, or it's going to convert another bytes format or something like that. It's going to assign the new bytes to this one, so that's what code type is. And co dot co argument count, it's going to count the arguments present in the function. And positional argument count, okay. uh, Only argument count, fine. That's and locals, the local the arguments which are there. Then stack size, it's going to print the stack size. Then the flags. Oh, here we see code and location. I guess this is where we are using as an input, no? So the location, what we got from the function, is being used here. Then plus charm, there is charm here. And what else is there? So this is plus location plus 1. Okay, so it's going to add that values into it. So then see cons and these names, local variable names, and all those things. It's basically it's an alternative Python bytes. If you get into deep details about how Python actually interprets everything in the interpreter, basically where it converts all the human readable formats into bytes and then executes our program. No, so that's where you'll understand these code objects. So, but in a very general manner, what you can say is that these are, it's like binary exploitation where we use GDB to disassemble the executable file, right? So, something similar to it where everything is broken down into pieces and then it's being presented here. In this case, that's what that is doing. And in this case, it's also modifying with the location and the charm that we're giving, right? That's what it's doing. It's also adding a location to it. Fine, that's understandable. So then it's going to return the magic wand. Where is this mend that we took from here? So it's going to, after it modifies, it's going to come and put it here, and then it's going to subtract the count or the left chances left for us to mend it. Now print the van has been made. If we get any error, the mending failed. Okay. So the logic, what I see here is that it's trying to edit the bytes of the Python bytes of the code, and then it's trying to, what do we say, run the program, right? So with this, to actually go in detail and show you how the bytes are going to look, we can do it from another. Let me not modify this. Let me go to my test.py. So we can use a module called dis, okay, which is going to disassemble the entire Python program or a function what we specify. So import dis, and then I will add it here just before the uh, break out of jail. No, let me not there. Let me add it here because this is in the loop. No, so I want to see how it works every time I do it. Before I choose an option, I want this and then the magic wand. Let's look at the magic wand first, and then we'll get an idea about how the function is working. This magic wand, because this is where it's having the place to go to the eval function. Okay, so this is saved, and now let me close this and run this. Python 3 test.py. So this is how it's going to disassemble in your Python code. So this is how the bytes. So yeah, I don't know if I can see it here exactly. If not, if you do it in Windows or using PyCharm where you have an active project which is running, you can usually see something called as your project file name dot cpy or pyc or something like that, which shows the code bytes of the Python which is running. So before it actually goes through the system, it's going to convert into these kind of bytes and disassemble the program to make the program to run faster actually. So that's why we use this. Now I'm disassembling the same function, which is our the magic wand function, and then trying to analyze it, right? So we can see here it's going to load a constant. Basically, it's working with the stack memory, how it's going to interpret and things like that. Now here we can see it's loading the constant, the wiggle sign, which is this one here. Let me go to jail.py, this one here, and then it's going to load another one for spell and loading another constant, which is nothing, and it's going to do all those steps, right? So that's what is happening here. And now I guess we have an option to edit. No, that's what we are doing from the mend. This is the entire thing. What is present in the code, no, that's what is this disassembled program is. But it's going to be, because there are so many other things, it's going to be in more detailed one. But it's a similar disassembled manner it's going to look like. So with the option of what is here, yeah, with the option here, from the print to statement, we can try and edit the functions here, right? That's what we are doing. So let's run this and see what's going to happen. So enter integer or location that you want to do. So I'll just give the value as 2, and then enter enchantment that you would like to do. So 3, just as a random thing, and now we can see that it has changed the thing. So that is 2, and here we had as load dot constant, whereas you can see here it's 2 again, but it has interpreter exit. So it's basically an Python opcode which is being used, the interpreter exit. Okay, so load constant is the thing. Now, fine. And this place is empty because we did not assign any proper value to it. So that place has been left empty. So we can edit the stack now. So we understand that we are able to manipulate the stack, what is here. Let's try one thing. Let's try this. I've exited this program. Let me copy this entire raw code which is there and paste it here. Now go here. Then I'll import the disk. Then just before I do this, I'm going to print, no, I'm going to add this dot disk, then magic wand, save it. Here, let's run the program. Okay. So if when you have so many functions, no, here, like print and all those things, it's going to occupy a lot of space because, okay, I'll just show you here. So we had so many print statements in between. That's what these things are. So print, null, and all those things. So if you, this is going to manipulate the stack, what is there. So that's why I've kept it, I've removed all those print statements, what I added to show how it's going to be printing out. So this is the stack of it. Now we have a actual stack on how the program is actually running. And since we're able to edit it, what we can do is we can modify this. No, the now when I entered the command as 3 here, 2 and 3, 3 has an opcode. I don't remember it right now, but it's an opcode which says interpreter exit. So what if I find an opcode which I can pass it here before it just edits it? That's what I'm thinking. So now instead of this function actually going through, I can modify this location because this is 0, 2, that's the location of it. And then load constant. Instead of that, I can change it to something else. Let's try that. Okay, so it's outside the loop, I guess. Yeah, it's outside the loop. So copy it here. No, cut. And then I'll paste it in here. Save. Now let me run this again. So we got this. Okay, so I'll choose 2. The location is 2, and then let me the opcode. So let's Google search that. Python opcodes. The first one, yes. Now let's find for the jump forward. JUMP underscore forward. Then yeah, so it's 6. Okay, so this is in 6e. So let's convert it into decimal. In decimal, yeah. What is the value? So it's 110. Let's come here and then enter 110. So if I press enter, now I can see it says 2 and jump forward 2. It says 1 and to 6. So it's going to load to the 6th one, which I don't want. Now, the whole reason that I want to do is because I don't want it to directly go through all this process. I want it to directly jump to this position to eval and spell and whatever that thing is, because then I can run some system programs inside it. But if it goes through all this process, no, that's not possible, right? So let me say it should go to the where is the stack? Where is it in stack? The eval function, it's here. So 62. Fine. So let's say 2 and then integer value 3 because I want to enter it here instead of that one. It's going to go there. And where do I want it? So how far is this from? So one back into our maths here. So 62, and currently it's in the fourth position. So minus 4 is 58, and it has two values in it. Difference is, so it's 29. So 58 divided by 2 is 29. I'm hoping this is the right maths what I did. But yeah, press enter. So now it should say now jump to 29 steps forward. That is to 62, and here we are. So load global, and this works fine. So that means now we can run anything as a command inside the eval function. So I just need to enter some value here. So I'll choose 1. That's what is happening here now. So coming here to 1, then it's going to take the result to us and then pass it to the function here, and then it's going to run to the eval function. Fine, let's try this. Now, because this is modified, the stack is modified, any input that I'm going to be giving, it's directly going to be going to the eval function. So what if I give open? It's a Python command basically. Open. We have we had flag.txt, I guess. So dot slash flag.txt. Then keep it there. Also read it. Yeah. What did we get? Oh no, the spell failed. Spell failed. Why is that? Okay. Let's try it again. Once again. Your spell is open dot slash flag dot txt, then read it, press enter. Okay, I was expecting it to print out, but what was that? It's reducted. Okay, now let's try it inside this itself. What was our thing? Let's open it here. So Python 3 test.py. We can look at these things here, side by side view. Enter value is 2 because I want to modify the stack. Then enter the location. The first is going to be the second location. So 2, and then enter the enchantment. So this one we had got it as 110, which is going to modify the stack. Okay, let's do it side by side so that we don't do anything wrong. 110. So now the stack has been edited. Again, go to 2, and then to the third location, and then the value was 29, I guess. 29 to 62, yes. The third position and the 29th forwarded there. So the stack is ready for us. Let's do 1, and then enter your spell. Open dot slash flag dot txt, then dot read. This should do it. Oh no, it's failed. Why? Why did it fail? Where is that command? Oh no, it failed. Okay, but why? So a return function elf. Okay, this is added, so that's an invalid thing. Okay, let's try it again. 1, and do you spell open, then dot slash flag.txt dot read, and then I'll comment out everything that is there after that. So oh no, it failed. It again failed. Fine. Is it because it does not find the location? Open. I'll give it as slash flag.txt dot read, and then the comment. Yeah, now we got the flag. So I guess the directory listing was not right. It was looking in the present directory, whereas it was in the root directory or wherever that was. Okay. So we got the flag now. That's good. Let's try with this also. This did not work, no? So now I want to write the spell open slash flag.txt and dot read, and then comes the person or the comment. Here it should say, oh no, the spell failed. I don't know now. Okay, but here we got the flag. Yeah, that is it for this video. What we just did was to understand and then reverse engineer the process of how the code is being written, and then to manipulate its stack by disassembling the Python's bytecodes. Yeah, so this was a pretty short video, I guess. Hope you learned and enjoyed this video. Please do like the video, and then you can comment down if you want to give some suggestions or any improvements, or if you want to suggest me for the next video, please do comment down below. And also share and subscribe to my channel for more contents like related to cybersecurity and CTF. They're coming soon. That's it for this video. Thank you.